Hello and welcome back. In the last few videos we talked about how to solve systems of linear equations by substitution and elimination. Now in every one of those examples that we did, we noticed that there was always only one solution. But technically there are also two other possibilities, to have no solutions or an infinite number of solutions. In this lesson we're going to be talking about the case where we have no solutions. So what do we mean when they have no solutions? What would cause a system of linear equations to have no solutions? Well, that would basically mean that they do not intersect. The lines do not intersect. So why don't we consider this first equation, y is equal to 2x plus 4. And let me graph this on the grid. And now I'm going to consider another equation, y is equal to 2x plus 1. Again, I will graph that line on the Cartesian plane. And now we have a system of linear equations. Now notice that these lines never intersect because they are parallel to each other. So we would say that this system of linear equations has no solutions. In general, we will notice that two lines that have the same slope but different y-intercepts will always have no solutions because they are parallel to each other and will therefore never meet. Again, we could also consider the line y is equal to 2x minus 3. Graphing that line, we notice again that they are parallel and therefore will never intersect. So there is no point of intersection and therefore no solution. And again, notice that these two equations have the same slope but a different y-intercept. So that's pretty simple. If we're given two equations in point-slope form and we notice that they have the same slope but different y-intercepts, then it should be pretty easy to tell that that system of linear equations has no solutions. But we won't always be given equations in point-slope form. We can also be given equations in standard form, and at that point it might be a bit more difficult to tell whether or not the two equations have no solutions as a system of linear equations. So let us consider the two equations 4x minus 8y is equal to 4 and x minus 2y is equal to 2. So both of these equations are in standard form. If I want to solve this system of linear equations, because they're both in standard form, I'm thinking that I want to use elimination. I'll rewrite the equations again over here. I notice that I can't eliminate any one of the variables x or y right away. So I'm going to divide the first equation by 4. That will give me x minus 2y is equal to 1, because 4x divided by 4 is x, and 8y divided by 4 is 2y, and 4 divided by 4 is 1. I'll rewrite the second equation again over here, and now I notice that I can eliminate a variable. In fact, if I subtract the first equation from the second, both variables will be eliminated. I'll have x minus x is equal to 0, negative 2y minus negative 2y is negative 2y plus 2y, which is 0, and then 1 minus 2 is negative 1. So I have 0 plus 0 is equal to negative 1, or 0 is equal to negative 1. Now hold on a second, that statement doesn't make any sense. How can 0 be equal to negative 1? They're two different numbers. So whenever we get a statement that doesn't make sense, that tells us that one number is equal to another, we can conclude that the system of linear equations has no solution, as in this example over here. And you'll notice that if you sketch these two lines, they will not intersect. They will be parallel to each other, and therefore there will be no point of intersection. Okay, I'll do one more example. In this case we have one equation in standard form and another in point-slope form. So because of that, I'll use substitution. I'll rewrite the first equation over here, and then I will substitute the second equation into the first equation, and I'll have x minus 3 times 1 over 3x plus 5 is equal to 6. Okay, so if we distribute the negative 3 to both terms in the brackets, we'll have negative 3 over 3x minus 15. So we'll have x minus 3 over 3x minus 15 is equal to 6. Right, because negative 3 times 1 over 3x is negative 3 over 3x, and negative 3 times 5 is negative 15. Now notice that 3 divided by 3 is 1, so the 3 over 3x becomes x. I'll have x minus 15 is equal to 6, and therefore I'll have negative 15 is equal to 6. Now again, that statement does not make any sense. Negative 15 is not equal to 6. So because we have a nonsensical statement, that means that there is no solution. Okay, so again, if we were to graph these two lines, we would find that they would be parallel, and therefore there would be no point of intersection or solution. So again, in summary, if you're ever given two equations and you try to solve them using substitution or elimination, and you get a statement that doesn't make any sense, that tells you that one number is equal to another number, then you can say that that system of linear equations has no solution. So that's all I wanted to go over for this video. In the next video we'll go over the third case, which is infinite solutions. But for now, as always, thanks for watching.